This lesson is Pythagorean Theorem using board number 17, the dry erase markers in the cloth, and the multicolored geometric shapes, both triangles and squares. First of all, we're going to have students draw a triangle by plotting three coordinates on the board. These three coordinates are going to be 5, 5, 5, 7, and 7, 5. So we can see that there is a triangle that's formed here. And I'll just shade that in. And the base is 2 and the height is 2. And then the hypotenuse, which is the opposite angle from the right angle, the longest side in a right angle triangle, is unknown. We would have to calculate that. So what we're going to do is we're going to show the relationship between these two sides, and normally those are called A here and B here, and the hypotenuse is called C, or labeled C. So the relationship in Pythagorean Theorem for right angle triangles is A squared plus B squared equals C squared. So we're going to demonstrate this visually using the squares and triangles in the kit. So what we're going to do is we're going to take the number 3 square, which is a 2 by 2, which has the exact same length and width as the base of this triangle, and the height of this triangle is also 2, so we're going to use that square. So to show the relationship for A squared plus B squared equals C squared, we're also going to have to use two triangles in combination, and that will be number 21. So what we've just shown here is that A squared, which is 2 times 2, is 4, plus B squared, which is 2 times 2 is 4, equals the square of the other side. Now obviously we have to calculate this, and we would get 8 equals C squared, so C is the square root of 8. Now that part is the mathematics behind it, but let's show students that if we calculate the number of triangles underneath here, that they're the same as the number of triangles underneath this. So we can see that A squared, which is this 2 by 2, plus B squared, which is 2 by 2, is going to equal the same dimensions as this. Now be careful, because the hypotenuse on this board, or the diagonal lines, are not the same length as the lines that run horizontally and vertically. So what we have to do to show that they are equal is to calculate the triangles. So we can see underneath here that we have half a square plus half a square plus half a square plus half a square. So this underneath here is 2 full squares. And then another 2 full squares, another 2 full squares, and another 2 full squares. So we now have 8 full squares, and under here we have 1, 2, 3, 4, 5, 6, 7, 8 full squares. So when we add A squared plus B squared, we get C squared. Then we can use a calculator to verify that C is equal to the square root of 8. So this is how you will show the Pythagorean theorem and its relationships between the side lengths, specifically A squared plus B squared equals C squared.